If we're given a 4 kilogram cup with an applied force of 6 root 2 newtons and mu of 0.1, and we need to find the acceleration of the cup. First, we need to find the net force in order to find the acceleration, and to find the net force, we have to draw a free body diagram to determine the normal force from the applied force, from the components of the applied force, and the friction force from that normal force. So, to draw this free body diagram, we have the cup, we have gravity force, we have this applied force, we have normal force, and we have some value of a friction force that we don't know yet. And we need to find this one in order to find that one in order to find that one. So to begin with this applied force, we have it as 6 root 2 newtons. So if we break those into components, we get 6 newtons and 6 newtons. And in order to find, oh wait, let me back up. And because it's 4 kilograms, we know that it's going to be a 40 Newton force of gravity. So, in order to find the normal force from this information, because it's not being like moved up and down in any sort of way, we need to create this equation, which is that the normal force plus these 6 newtons from the applied force minus these 40 newtons from the gravity force is going to equal 0. And that gives us a normal force of 34 newtons. And then we can use this normal force to find the force of friction, because the force of friction is equal to mu times normal force. And so if we multiply 0.1 by 34 newtons, we get 3.4. And so our friction force is going to be equal to 3.4 newtons. Newtons for both. All right. Now that we have our friction force, we can start to balance out what we have here. So we'll be able to take this 6 Newton applied force in this direction and subtract the friction force from that. So 6 newtons minus 3.4 newtons is, we're going to get 2.6 newtons for, and that is going to be our net force. So F net equals 2.6 newtons. And in order to find the acceleration, which we need the net force for, because our equation will go acceleration equals net force over mass, we just divide 2.6 newtons by the mass, which is 4 kilograms. And that gives us 0.65 meters per second, because the units of kilograms cancel out and we are left with meters per second.